You are listening to Radio Data, a podcasting radio where we talk about data, cloud, analytics, and AI with different guests, different hosts, and in different segments. This segment is called Data Journey, where our guests talk about how data moves around in their company, what technologies they use, and what value data brings to their products. Radio Data is recorded with passion by Getting Data. Getting Data is a data management company founded by ex-Spotify data engineers who now build similar cloud, AI, and data engineering solutions for other companies. Hello everyone. Today our expert guest is Victoria Bukta. Victoria works as a senior data engineer at Shopify. Shopify is the e-commerce company that I believe most of you recognize. Shopify is also a very early adopter of cloud and big data technologies. I will be talking with Victoria about her experience with big data technologies, especially Apache Iceberg, and the data engineering projects that she has been implementing recently. Let's start with the introduction. Victoria, could you please tell us more about yourself, your background, and your company?
Sure. So I'm based in Toronto, and I'm actually a graduate of the University of Toronto. So I'm Toronto born and raised, basically. And I studied computer science. And Shopify was like my first job outside of university. So I did some internships beforehand. But Shopify, it's one of the biggest Canadian, I want to say the biggest, well-known Canadian tech companies. And they had an office in Toronto. And even though Toronto's a big city, a lot of people know each other. So actually, one of my mentors at the time referred me, and that's how I got into Shopify. And they also did presentations at my university. I remember the first time I saw Toby, our CEO, was actually they had sponsored a hackathon at U of T. And here's this guy who comes on stage with no shoes on. Like whenever Toby speaks, he's always in socks, and he has like the funkiest looking socks. So that was like super memorable. And at that time when I was in school, this was like back in maybe 2013, no one really knew what Shopify was. It was still like this little startup kind of thing. People didn't know about it globally. So things have definitely changed. When I joined Shopify, I was hired as a data engineer. And it was really, really funny because at the time, I didn't even know what a data engineer was. I was just some kid who graduated from university, who studied computer science. I focused my studies on systems, so I took lots of hardware classes, some work in distributed systems. I was also interested, I guess, in data, but like in AI. So I took some machine learning classes and things like that, some computer vision classes, and I guess it was a natural fit. But kind of coming out of school, I only thought there was two routes. There was front-end development, there was back-end development, and you kind of choose. So I remember going through the interview process at Shopify, and at the last that last interview was just about like why I wanted to join and why I wanted to be a data engineer, and I was like, I don't even know what that is. it was super, super funny. But I liked data, and I liked the potential of the things that you could do with it. So it seemed like a natural fit. And the team that I joined was called Data Acquisition. And primarily the team, and it's now been rebranded. I'm on the same team. We're called Lakehouse, but we're responsible for the raw data ingestion into the data warehouse or data lake. So we collect data from relational databases, event data from Kafka, or even like API data from third parties that like Shopify might integrate with. So we were responsible for all of that. No transformations at all. The only transformations we do is basically around PII, if anything has to be scrubbed before it gets into the warehouse. Or even if we do collect PII information, doing things like retention on that data, so it's purged after so many days. So that was what I started doing. And at the time, I kind of became the de facto maintainer of this tool called Longboat, which was our statement-based replication system. So essentially, it would run a series of SQL queries to get data out of a relational database and dump it to GCS. So we're completely on Google Cloud Platform. So we would collect this data, we would write it as Parquet files to GCS. And I think similar to like a lot of other companies, we basically, our data set constituted like, you would have a folder that was like your data set name. So let's say like Shopify shops, this represents all the shops that we have at Shopify. And then you'd have a bunch of timestamp folders, which was our way of versioning the data. And then in one of those folders, you have all your Parquet files. And I think this is a really good segue into what I'm doing now with Apache Iceberg. You can imagine that stops scaling, and a lot of the other, we ran into problems where it was really hard to make changes under the hood to how we store our data or even maintain our data after we write it. So, especially in the case of the Kafka data, you're delivering data on a schedule. We would do like micro batch, and you can have lots of small files, and this is not performant from a query perspective. So you might want to go back after the fact and coalesce those files into larger files. So this would be more optimal from the query engine on the read side. But doing that with the system that we had in place, I guess at this point I would call it a table format, and our table format is basically these timestamp folders. It was really hard to change the data without any downtime to consumers. We would have to basically lock the table completely. And that's what made Iceberg really appealing, is that now we can have transactions with our data, and consumers, and for us, a consumer is basically the other modeling teams. We have modeling teams on top of the raw data who are running Trino, who are running Spark, and they have a framework on top of those systems for data scientists to build models. So it's in there that they need to refer to our data, and they were really tied to the implementation details of like these timestamp folders and how that was all laid out. So we're in this transition now of moving away from that and using Iceberg, referring to everything as a table and being able to have transactions, and that like we have the flexibility to change our data under the hood, like coalescing files and things like this, without impacting those teams.
It sounds really interesting. Please let me rephrase. Do I understand correctly that your goal is to collect a lot of data from various data sources and then store them in a central location, and you use Apache Iceberg as a format for your analytics tables? Then different teams can actually process and analyze this data using their favorite technologies such as Spark or Trino.
Exactly. And like, it was really funny the way that we ended up at Iceberg. Actually, we weren't looking at modifying our table format at the very beginning. One other thing that I didn't mention that my team is responsible for is we produce a data set that we call a snapshot. But basically, we get all these incremental changes from a relational database, and you want to fold them together to produce what is the current state of the production table at a specific moment in time. So today at 9 o'clock in the morning, this is what like the Shopify shops table looks like. We want to produce that as a data set for other people to build off of. Now, doing upserts to a immutable file format like Parquet or ORC, like some sort of columnar format, is inefficient. Like, it's immutable for a reason. You have to put the whole file into memory. You have to do your modification and write the file back down. So upserts are really, really difficult. So what I was really interested at first about Apache Iceberg, and this was back in 2019, was they had this proposal for their V2 spec, which is now released, where you could do row level updates. And the way that you could do row level updates is by appending to your table what they called a delete file. And what the delete file is, it is basically a filter where you can specify which rows in the data set do you want to filter out. So with a combination of appending data files, appending delete files, and then more data files on top, you could essentially perform an upsert, but you haven't actually rewritten any Parquet files. So the filtering happens on the read side. So this technique that they developed, they're calling it like merge on read. So the merging, the modification happens on the query engine side when someone is querying the data set. And what's so powerful about this is that I can accumulate updates until I deem that it's necessary, that I'm putting too much load on the read, on like the query engine side. It now makes sense to actually perform the rewrite. And now I can almost have a streaming application performing upserts and deliver data much faster, instead of before we would have data sets getting updated every, like, let's say 6 hours, these snapshots getting updated every 6 hours. Maybe now I can produce them every 15 minutes, right? And then have a compaction job that runs like every hour, every 2 hours. And then as a data scientist, you can choose, do you want to query the data set at its freshest state? So you understand that your query might be slower because the query engine has to perform the upsert. Or do you want to query it like the data set as of 2 hours ago, let's say, where the table has been optimized? So you can have that flexibility. So that was really interesting for us.
If I understand correctly, you can also rewrite your datasets to avoid expensive merge on read operations, right?
Yeah, so you can rewrite the data sets so you can avoid merging on read. And you can basically collect the updates. And then when you've determined you have enough updates that it requires a rewrite, you can go rewrite the data set.
Yes, it's very good, especially because you mentioned that you use Google Cloud Platform, so I believe this might help you lower the costs of using the cloud in the pay-as-you-go pricing model by saving some compute resources.
Yeah, so it depends on how you have everything configured. So for us, we store all our data as files in GCS. So there's a fixed cost for data, right? For whatever you're storing. And storage is super cheap, like relative to, so let's say, a service like BigQuery. BigQuery is really expensive, especially when you start using it at scale. If you want to scan a lot of data, you're paying for like basically every row that your query scans. You're paying per query. So for us, we have a team called data infrastructure that's in charge of running our Trino clusters, our Spark clusters, and they just access the files in GCS. And by running all of that in the same physical data center, you don't have to pay for transfer costs of the data. So if you were to have data in physically two separate data centers, you'd have to pay a transfer cost for the data to move to one place to another.
You also told something interesting. You use Google Cloud Platform, but you also have a number of open source technologies in your data platform and data pipelines, such as Kafka, Spark, Iceberg. And my question is, how do you choose between open source and vendor-specific cloud-managed technologies?
I think we have a really interesting history at Shopify because we were there for that pivot between people having to manage their on-prem data centers to cloud having a vast offering. So when I started at Shopify, we actually weren't on the cloud at all. We had our own on-premises data centers. And within my first year, there was a big move to the cloud. So of course you have to pick a cloud vendor. I think at the time, so this was 2017, 2018, at the time, Azure wasn't as developed. So you had two big cloud offerings, which was AWS and GCP. Of course, Amazon, being an e-commerce company, is a big competitor. So maybe it's not the smartest choice. So basically that meant that Google was the natural choice at the time. And we ran a lot of open source software, but there is a lot of stuff. When we did move to the cloud, we adopted like BigQuery and some other services like Dataflow. And I think as we've grown as a company, we've realized that we are big enough that it would make financial sense to manage those services ourselves and to have the flexibility and customizability to run our own forks and develop our own features internally to those projects. So actually over the last few years, I think we've actually made a conscious choice to choose more open source technology. It's like, why Kafka and not PubSub, for example, right? We're moving away from BigQuery to doubling down on Trino. So we're making like all of those transitions right now. And I think that came with scale, really. So those cloud services, they're super great if you don't have the staff and you don't have complicated needs. And at some point you outgrow that.
Yes, I understand. However, when you mentioned that you have own Kafka cluster, is this the cluster that is managed by your colleagues at Shopify, or it is a cloud managed service, for example, from Confluent?
So that's a really good question. So we have our own internal Kafka team where we run our own installation of Kafka. So we manage it all ourselves. Yeah.
And how large is Shopify in terms of data collected and processed, so that it makes economical sense for you to run own installation of open source technologies on top of the cloud?
Right. So in terms of, so I don't know about the whole platform as a whole, but I can speak to specifically my team that's doing ingestion. And we're kind of in a transition point because we're adopting, anyway, so right now I would say that we probably collect close to like a petabyte of data a day. Now, that doesn't mean that we're growing by a petabyte of data every single day, because a lot of that data is PII data and gets purged from the warehouse after X number of days. So we have a lot of, and most of that data is stuff that's coming from front-end applications. So we're doing lots of event collection. So every time you go to like a Shopify store and you're clicking around on a store or interacting with the checkout, there's all sorts of events being collected about user behavior. And this constitutes, I think, the biggest amount of data on our platform. Now, a lot of those events aren't very interesting. So there's lots of data science models and things that are doing all sorts of aggregations to get the important facts about what's happening out. So they don't actually need to hold all that data in the warehouse permanently. But that can give you kind of a sense of scale of like how much data is actually coming in.
It's definitely a very large scale, and I assume it will continue growing because of the obvious trend that consumers are shopping more and more online. So it's likely that you will have more data sources, more pipelines, and more use cases in the future.
Yeah, and maybe I can speak to the data sources one for just a second. And one of the big projects my team has been working on over the last year is the adoption of CDC data. So CDC standing for Change Data Capture. So we're working on collecting every single change to a relational database, pumping that through a Kafka topic. That part is actually done by a separate team, but where we come in is collecting that data out of the Kafka topic and archiving it in the warehouse or the data lake, using Apache Iceberg and using Kafka Connect as like the consumer, and then writing Iceberg tables. So that's the current project of my team. And this project hasn't been finished by any means. We're kind of in the productionization phase right now, but you can imagine this will explode, the amount of data that we're pumping into the data lake to have available to our data scientists.
Does it also mean that you would like to reduce the latency of your pipelines and ingest data faster?
Exactly. So have more data faster, to have something that's a streaming application, updating data sets. So basically, we will be providing two different kinds of data sets. One is the CDC archive, which is like an append-only table where you have every transaction to the database or every change to the database. And the other is that snapshot that I was talking about earlier, where we are doing the upserts and producing at a specific moment in time. This is what the production table looks like.
Okay, and do you also use a technology called Debezium for CDC?
Yeah, so we use Debezium for getting the events out of the databases. So it basically, for people who don't know, it basically tails the binary log, which is like an audit log of the production database. And this is traditionally used for database replication between two databases. So if you want to have like a primary, secondary database to fall over to, but we're using it, and what Debezium does is it takes those events and you can pipe them to Kafka as Kafka events.
So this is one more open source technology in your data pipelines.
Yes.
Awesome. We talked a lot about the technologies that you currently use, but let's talk about the future. What are new technologies that you think you will be evaluating or maybe even using at Shopify later this year or next year?
So my biggest interest lately has been catalogs. So right now at Shopify, and what we use for Iceberg, you require like a catalog to keep track of your tables and changes to the tables. We use a Hive meta store to do that, which is quite traditional, another open source technology. But there's new kinds of catalogs that have been coming out. So I'm really interested in Project Nessie. There's another one called Lake FS. And I think last week I was at the Subsurface conference hosted by Dremio, and they announced their catalog called Arctic, which is actually just a layer underneath. It's Nessie, but on top they have some extra stuff. But what's really interesting about these new catalogs is that they're saying that they want to promise something like a Git-like experience for your data sets, for your tables. So think about, you have your main branch, your published version of your table. You branch off of that. A data scientist, or maybe for machine learning, you're running a bunch of experiments. There's a bunch of stages to your experiments. You do some auditing, and then you merge the changes into the main branch of your data set. So it's a kind of a non-linear way of dealing with versioning. And I think this is going to be the next transformation. In my opinion, I think it will be the next thing that will take data lakes and data warehousing by storm.
Yes, I totally agree with you. Personally, I also see that there are new tools created and used for data catalogs, data discovery, data lineage, and data quality. For example, Marquez or Amundsen to name a few. Actually, all data companies need such tools, but not all of them have started using them yet.
Exactly. Yeah, and I think another big topic, this is not like a technology, but I think another interesting thing that companies will have to start dealing with more is data residency. And I know that there's been various privacy laws in different countries and different regions like the EU or in California that companies have had to adapt to. But I think it'll be a growing trend where consumers will want to say, use a product and say, like, I don't want my data to leave certain borders. Or maybe I think governments and regulated industry will become more and more strict on how companies treat their data. So say like in healthcare, if you're a health tech company, most of the data centers are in the United States. If you're an EU company, how do you feel about your medical data being stored over there? So I think people will become uh, people are becoming more educated about the consequences and are becoming more sensitive to how they treat their data and how they expect companies to treat their data. And this will become an interesting revolution, I think, for data lakes and data warehousing. And you can kind of see the complicated problems that this proposes. Storage is one thing, but what about compute? If you want to compute and model, can my data leave the EU? Does it have to be modeled in the EU? What can leave the EU? Is it only some sort of aggregation? So these are like interesting problems that I think will be longer term that we will have to figure out.
That's true. There are many companies that have specific regulations for data residency. For example, today I talked to an engineering director from the healthcare company who will be speaking at the Big Data conference that we organized in late April this year. He told me that they are building a unified global platform for processing electronic medical records. They built it in the cloud, and data residency is very important functionality for them, and it impacts their data platform architecture in a very significant way. So in other words, they would love to build as unified solution as possible, but they need to take into account many local requirements such as privacy, security, and governance that are often different in various countries. Yeah, and we are slowly running out of our time, but let's conclude our conversation by talking about your presentation at the conference that we organized in April. Could you please tell us more about what would be topic of your presentation and what the audience can learn if they attend your talk?
Right. So I'm going to be talking about Apache Iceberg and Shopify's adoption of Iceberg. And I've been to lots of conferences where people have done talks about how Iceberg works. And I'm definitely going to touch on that, but I'm not going that's not going to be the focus of my talk. What I want the focus to be is more broadly about what considerations should you make to actually storing your data? What are the benefits of Iceberg? But also, if you're adopting it, what other things can you start thinking about? One of the things that we started thinking about was, should we store all our data sets in a single bucket? Should we think about actually having a bucket per data set? That might sound kind of wild, but at the same time, this gives you a lot of insight into who's accessing that data set. What is the cost? It's much easier to get the cost of what that data set is costing you. You can then forward this bill to, teams. Do you really need this data? Honestly, I think that 80% of the data that we collect isn't being used and isn't worth keeping around. And I'm sure this is a common feeling between data engineers, but being able to have setting up things in such a way that you can actually calculate this. Even like access, We always like to think that we will never have a bad actor internally in the company, but it's always entirely possible. So being able to trace the steps of who accessed exactly what and when, this becomes much easier. And then permissions, every company will have some sort of sensitive information that they're keeping around, and making sure that that's isolated properly. So when we adopted Iceberg, these were a lot of the big questions that we asked ourselves, to rethinking of how we would architect our data lake. So this is what I also want to talk about during the talk.
It sounds very interesting, and I'm sure it would be a very practical presentation based on real challenges and problems that you have solved. So I encourage everyone to attend this presentation in Warsaw. You also mentioned something interesting, that around 80% of the data that is collected is probably not useful. I have a similar feeling, and this is not only related to the data collection part, because later you have many data processing steps that generate many intermediate data sets. So I'm sure that everyone can find many data sets in his or her own data lake that are not needed because they were generated as a byproduct of ETL or analytics pipelines, or maybe some ad hoc queries, or maybe even automatically generated new versions of your machine learning models when prototyping and training those models. For instance, when I worked at Spotify, we have accumulated so many of no longer useful data sets, and we later needed to implement a special tool to discover the data sets that are no longer consumed by anyone and delete them. So any automatic tool that can discover data sets that are no longer useful for anyone and remove them quickly will save tons of money to any company.
Yeah, I feel like this whole idea of purging and putting limitations on data collection, or like historical data, this is like a company maturity thing, where I think really early on, people are really scared. They may not be using it, but they're like, one day I can envision this team coming along and doing something really interesting with the data. And it takes a lot of maturity for someone high up to put their foot down and say, no, it's time to let go. Yeah.
Yes, you need to be very pragmatic, because otherwise you will have so many useless data sets in your data lake, and they will cause many problems for people who consume them.
Yeah. And like at Shopify, specifically just the data sets that are produced by my team, we're talking in the magnitude of, we produce 8 to 10,000 unique data sets. And those are raw, right? That we manage. And then you can imagine how many data sets are produced like afterwards, the modeled or machine learning stuff. So it's a huge amount of stuff to keep track of and to clean up and manage.
Absolutely. Now I would like to thank you, Victoria, for speaking with me in this podcast episode, and especially for sharing your knowledge with our audience. Thank you very much for this. If you are interested in new episodes of Radio Data, please follow us on Acast, Spotify, and other podcasting platforms. Also visit gettingdata.com to find more information about other ways that we gather and share the knowledge.